9 is about multiplying matrices. Now, a few weeks ago we talked about adding and subtracting matrices. When we did that, we had to find the dimensions first, and then if the dimensions were the same, then they could be either added or subtracted. Today we're going to multiply these matrices, and we still have to do a lot of the same things, but the process is going to be different here. Our first step of doing this would be to figure out what the dimensions are for each one of these matrices. Alright, dimensions for A, remember it's rows by columns. So we've got 1 row by 4 columns for A. For B, we've got 4 rows by 1 column. Alright, now that we have these, could we add or subtract these? Absolutely not, they're not the same dimensions, but we do have a chance of multiplying these. So how we would do that, we would have to, notice that I wrote these in this order on purpose. I would, first of all, I'd look at my middle numbers here. If these two are the same, that tells me that I can multiply them. If they're different, I cannot multiply them. Alright, so then I just put a no solution and I move on to the next one. If I can multiply them, then my outside numbers are going to tell me something important too. My answer is going to be a 1 by 1 matrix. So I'm going to have a matrix here with just one spot in there. Alright, and how we find that one spot is we're going to take this entire row times this entire column and add them together. So to get that one spot, we would take -3 times 5 plus 2 times 0 plus 6 times -1 plus 4 times 3. Alright, so -15 plus 0 plus -6 is -21 plus 12. Our answer for AB is -9. Alright, we take our row times our column to be able to get that. Now, what it does say is it also says, figure out if we can multiply B times A. I'm going to get rid of this, and we're going to try and do B times A now. Now notice that these are in a different order here. B times A, we've got 5, 0, -1, 3. Now I normally rewrite these in the right order because I need to be able to see them in the right order. Whether you have to do that or not totally depends on you. But there's our B times A. Well, our B, as we said earlier, is a 4 by 1. Our A is a 1 by 4. Once again, look at the middle numbers. They're the same, so we can multiply these, and our answer is going to be a 4 by 4 matrix. So what that means is we're going to have 4 rows and 4 columns here. So we're going to have a lot of work to do to be able to solve this matrix. Now notice what I did here is I put in all of those spots because I know that I have got to be able to fill in every single one of those blanks. Alright, this spot right here is in the first row, first column. So what I'm going to take is, I'm going to come over here, and I'm going to take my first row number times my first row column. Well, 5 times -3 ends up being a -15. The second spot, row 1, column 2, I'm going to take 5 in the first row times my column 2 is 10. My third spot, row 1, column 3, 5 times 6 is 30. And then my last one, 5 times 20. Now, what you are seeing here is, well, it looks like I'm taking this entire row times 5. And you're not wrong with that, when you have something, these are simple matrices to multiply. When you have that, that's what is end up going on here. Alright, so we're gonna take 0 times all 4 of those, and we would get a 0 for our second row here. For our next one, it'd be -1 times -3, -1 times 2, -1 times 6, -1 times 4. And then for our last row, we're going to take 3 times each one of those. So -9, 6, 18, and 12. And that's how we multiply those matrices. Alright, moving on to a little bit more complicated ones. Now we need to figure out if we can multiply A times B, and then we're going to see if we can multiply B times A. Alright, A times B, first dimensions, 2 rows by 3 columns. Matrix B, 3 rows by 3 columns. Alright, look at the middle numbers, they're both 3's. That's good, that tells us that we can multiply them. And then our answer is going to be a 2 row by 3 columns. 2 rows, 1, 2, 3 columns. Alright, now these are a little bit more complicated. Alright, our first one here, we are going to take and multiply to get this spot right there. We are going to take our entire first row, make this a little bit smaller, our entire first row by our entire first column. Alright, and this is where they do get a little bit messier, a little bit more work. So 2 times -1. Take the first elements times each other, and then the second elements times each other. So 3 times 4. And then 4 times 0. And we add all those together, and that's going to give us our first numbers. So -2 plus 12 plus 0 is 10. Then we go to our next spot. And it really doesn't matter whether you go down or whether you go to the right. I am going to go to the right here and fill in this spot. Okay, this is in row 1, column 2. So I'm taking row 1 again times column 2 now. So then I've got 2 times 4 plus 3 times 5 plus 4 times 2. And then we're going to add those together. So 8 plus 15 is 23, plus 8 is 31. And then we keep going. We go to our next spot. So I'm going to grab a yellow here. We want to fill in that spot. So that is row 1, column 3. So then we've got row 1 is 2 times 7 plus 3 times 2 plus 4 times 0. So 14 plus 6 is 20 plus 0 stays as a 20. Alright, now we're done with our entire first row up here. Now it's time to go down to the second column. Or the second row, sorry. So we're going to, I want to fill in this spot now. Well, what that is going to be is that's going to be row 1 times column 1. So I've got 4 times -1 plus 2 times 4 plus 5 times 0. 4 times -1 is -4 plus 8 plus 0 is 4. Then we go to our next spot, which is row 2, column 2. So I'm going to take row 2 times column 2 here, and we go 4 times 4 plus 2 times 5 plus 5 times 2, 16 plus 10 plus 10 is 36. And then our last one is in our third spot here, row 2, column 3. So I'm going to take row 2 times column 3 here, and I would go 4 times 7 plus 2 times 2 plus 5 times 0. We multiply those together, 28 plus 4 plus 0 is 32. And there's my answer. Alright, so it does take a lot of work to get each one of these, alright, but that is the process for it. To find b times a, we actually still have enough room up here to be able to solve this. The dimensions of b are 3 by 3. The dimensions of a are 2 by 3. Now we gotta look at our middle numbers. Those are not the same. So we cannot multiply these. So the answer to b times a is no solution. Alright, so there are two answers to finding a times b and b times a. Alright, sometimes it works out where you can multiply a times b and then you can multiply b times a, and you're not always going to get the same answer. If you look back here at our first one, we didn't get the same answer. We were able to multiply a times b to get -9, but when we took b times a, we got all of this. Alright, order definitely matters when you're dealing with matrices here. Alright, our last one, find a times b, and our first one here is a, our second one is b. Alright, so let's find that first. Dimensions of a, 3 by 3. Dimensions of b, 3 by 3. Dimensions are the same, and the middles are the same, and our outsides are the dimensions. So we've got a 3 by 3 matrix here. Alright, now to multiply these. Okay, we do the same thing as we did before. Alright, row 1 times column 1 to fill in this spot. Alright, well I've got 4 times 1 is 4, plus 3 times 0 is 0, plus 1 times 0 is 0, so I've just got a 4 there. To come over to our next spot, to get this one, we would do row 1, column 2. Alright, now take a look at this one. This would be 4 times 0 is 0. 3 times 1 is 3. 1 plus 0 is 0. So we're taking 0 plus 3 plus 0. We get a 3 here. Does that look familiar? It should. Alright, our next spot is over here. Okay, we are taking row 1, again, times column 3. Alright, so when we do that, we've got 4 times 0 is 0, 3 times 0 is 0, 1 times 1 is 1. Look at our first row of matrix A and of our answer. It's the exact same thing. Will that pattern hold? And for this, it actually does. If we were to come down here and to find this spot here, we'd take row 2 times column 1. So 6 times 1 is 6, plus 0, plus 0. There's our 6. This pattern is going to repeat itself. Alright? When we are multiplying by this special type of matrix here, this is like multiplying by using our multiplicative identity, where we have ones going in a diagonal pattern from top left to bottom right, and everything else is a 0. When that's the case, that's like multiplying by 1. So if you look at that, that's why our A turned into our answer. If we did B times A, we would be taking 1 times whatever A is, so then our answer is just going to be what A is there. Alright, these matrices, when we're multiplying them, these are new. Okay, these are going to take some work. Please make sure you're working on this, work hard on these, ask questions as you go. We will use these off and on throughout the year, so it's very important to be able to get this down now. Any questions, please let me know.